Hi, today we are going to learn about given one trigonometric function value, find the other 5 trigonometric function values. Let's understand how to find the trigonometric function values. Given a right triangle, suppose this is a right triangle ABC, this is the right angle here. The side opposite to the right angle is the hypotenuse. Suppose this is my base angle theta here. The side which will be opposite to the base angle is known as the opposite. And the side which is just next to the base angle is the adjacent. Now in order to know the trigonometric function values, we are going to use the SOHCAHTOA rule. Which says sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tangent theta is opposite over adjacent. Cosecant theta is the inverse of sine, multiplicative reciprocal of sine theta. So it's hypotenuse over opposite. Secant theta is the multiplicative inverse of cosine theta. So hypotenuse over the adjacent. And cotangent is for tangent. So cotangent will be adjacent over the opposite. Now if we take the base angle as the other angle of the triangle, then our sides will change. Suppose this is ABC. This is the right angle. If we take this as theta, hypotenuse will remain the same. This side will become the opposite and this side will become the adjacent. So keep in mind the base angle. Now let us look at the quadrant system. This is the coordinate axis XY. This is first quadrant, second quadrant, third quadrant, fourth quadrant. In the first quadrant, all trigonometric functions are positive. In second quadrant, sine and cosecant are positive. All other functions are negative. In third, tangent and cotangent are positive. All other are negative. And in the fourth quadrant, cosine and secant are positive. Rest other are negative. In first quadrant, we have x positive, y positive. In second, x is negative, y is positive. In third, x is negative, y is also negative. In fourth, we have x positive, y negative. So let us look at the problems now. Find the values of all 6 trigonometric functions. Theta lies in quadrant 1. Secant theta is 85/84. So secant theta means hypotenuse over the adjacent. So if we draw a right triangle, this is 85, this is 84. This is theta, 90 degrees. So we can find the opposite by using the Pythagoras theorem. Pythagoras theorem says that the square of the hypotenuse of a right triangle is always equal to the sum of the square of the other two legs of the right triangle. So here 85 square will be equal to opposite square plus adjacent square, that's 84 square. So opposite square will be 85 square minus 84 square. Opposite will be square root 85 square minus 84 square, which is equal to, opposite is equal to 7225 minus 7056. So therefore opposite is equal to square root 169, which is 13. Taking the positive root only, since sides cannot be negative. So now we can write the other functions. Sine theta, so opposite over hypotenuse, that's 13 over hypotenuse is 85. Ka, so ka 2a. Cosine theta, adjacent is 84 over hypotenuse is 85. Tangent, opposite over adjacent, so 13 over 84. So cosecant theta will be 85 by 13, multiplicative inverse of sine. Secant we already know, cotangent will be 84 by 13. So the ratios are sine theta is, since theta lies in quadrant 1, all functions will be positive. So the ratios are sine theta is 13 by 85, cosine is 84 by 85, tangent is 13 by 84, cotangent is 84 by 13, secant theta is 85 by 84, cosecant is 85 by 13, which is the answer in the D part. Next problem. Find the values of all 6 trigonometric functions. Y lies in quadrant 1. Cosine y is 40 by 41. Cosine means ka, that's adjacent over hypotenuse. So we need to find the opposite. So hypotenuse square is opposite square plus adjacent square according to the Pythagoras theorem. So 41 square is equal to opposite square plus 40 square. Opposite square is 41 square minus 40 square. Opposite is square root 41 square minus 40 square. So opposite is 41 square is 1681. That is 1681 minus 40 square is 1600, which is equal to square root 81, which is 9 units. So we can write the ratios now. Sin y, all ratios will be positive, y is in quadrant 1. Sin y will be opposite over hypotenuse 9 over 41. Cosine y is 40 by 41 given. Tangent y will be opposite over adjacent, that's 9 by 40. Cosecant y will be 41 by 9. Secant y will be 41 by 40. Cotangent y will be 40 by 9. So our answers are sin y is 9 by 41. Cosine y is 40 by 41, tangent y is 9 by 40, cotangent y is 40 by 9, secant y is 41 by 40, cosecant y is 41 by 9, which is the answer in the C part. Next problem. Find the values of all 6 trigonometric functions. Alpha lies in quadrant 3. Sin alpha is negative 5 by 13. Since alpha is lying in quadrant 3, only tangent and cotangent will be positive. Rest other functions will be negative. So sine is given by opposite over hypotenuse. So we can say opposite is 5 units and hypotenuse is 13 units. So let's find the adjacent. Adjacent square will be hypotenuse square minus opposite square. So adjacent will be square root of hypotenuse is 13 square minus opposite is 5 square. 169 minus 25. Square root 144, which is 12 units. So my sine alpha is negative 5 by 13. Cosine alpha will be adjacent over hypotenuse and it will be negative. So negative 12 by 13. Tangent alpha will be opposite over adjacent. That's 5 is opposite over adjacent is 12. Secant alpha will be negative 13 by 12. Cotangent alpha will be 12 by 5. And cosecant alpha will be negative 13 by 5. So our answer is sine alpha is minus 5 by 13. Cosine alpha negative 12 by 13. Tangent alpha 5 by 12, cotangent alpha 12 by 5, secant alpha negative 13 by 12 and cosecant alpha negative 13 by 5. Just the answer in the D part. I hope you can practice more problems on given one trigonometric function value. Find the other 5 trigonometric function values now. Thank you for watching. Have a great day. Bye bye.